In this example, we're going to look at a lot of interpreting slope and a little bit about composition. Composition will be a big deal, and you will see more of it in your homework because the chain rule is one of our most useful rules, and it's focused on taking derivatives of composite functions. So if you don't understand the notation that goes with that and can't pick apart compositions, you're going to have some trouble there. Okay, but let's start with identifying the slopes. So you'll see me do this a lot in problems just to help me keep track of what variables on what axis and those relationships. So our first function is r of x. So r is a function of x, and x is the percent decrease in the thickness of the ozone layer. This is just my scratch work. It doesn't have to be pretty. You can abbreviate. That's fine. It's just a reference. And R is the resulting percent increase in UV radiation. So this is a percent increase in radiation. And then we have a second function. Where is it? C of R, that one. And it inputs R's, which we already have. That's that percent increase in radiation. And it outputs C, which is the percent increase in the number of cases of skin cancer. So this is C, and that is percent increase in skin cancer. Okay, and we could even draw these. These are linear functions, so absolutely if you have something quick and easy, it doesn't hurt. Just a really rough sketch here. I'm imagining, okay, if this was like a slope of 1, this is just a little bit steeper than that, 1.5, positive slope, and it goes through 0, 0. And then C of R equals 3.5 R. So same idea, also goes through 0, 0, but it's even a little steeper. Okay, so rough, but that's what I'm picturing. So the slope of R and its meaning, to get back to the question that we were working on, the slope is 1.5. So I'm just thinking back to y equals mx plus b and snagging that 1.5 as attached to the x. So the slope is 1.5. And what that means, that's equal to change in y over change in x. It means every time your x value increases by 1, your y value will increase by 1.5. And to tack units on that, the x is the percent decrease in ozone, and the y is the percent increase in UV radiation. So what I'm seeing is that if the thickness of the ozone layer decreases by 1%, the amount of UV radiation will increase by 1.5%. That's what this is telling me. And this is a linear function, so that should be true no matter what x value you pick. If you're working on something curved, that value will change. It will be an average rate of change, but this is a straight line. So this will always be a 1% decrease in the thickness of the ozone layer, resulting in a 1.5% increase in UV radiation. Okay, so very similar for part B. Part B, we're going to refer to the green graph. We want to find the slope and explain its meaning. So again, looking back up at the green function, the slope is 3.5, and I'm going to put that over 1 again because again, that's change in y over change in x, or I guess it can be even more clear. For us, our y values are c, so that's change in c over change in r. So c is the percent increase in skin cancer, and R is the percent increase in UV radiation. Okay, so if I'm going to do a full explanation here, and your full explanation should be a complete sentence that includes the numerical values and the units, I would say a 1% increase in UV radiation causes a 3.5% increase in skin cancer. Or for every 1% increase in UV radiation, there will be a 3.5% increase in skin cancer. So something along those lines. You will have some online homework that will just ask you to fill in some blanks, things like that, but you should be able to write these out fully as a sentence. Okay, last but not least, find C of R of X and then identify slope, explain meaning. Okay, so C of R of X is saying take the function R of X, which is equal to 1.5x, and plug it into C. So you're going to take the equation for R of X and plug it into the formula for C. These are really simple, which actually sometimes makes it a little harder for people. So I'm looking back up here at the formula for C. It says, whatever input you give me, I will give you back that input multiplied by 3.5. So we just need to take that 1.5x and multiply it by 3.5. And I'm getting for that 5.25. So our formula for C of R of X, just to summarize, C of R of X is equal to 5.25x. So its slope is 5.25 over 1, but we have to be really careful about this one. What it does is it inputs an x and it outputs a c. So its axes would be an x and a c. So this is now the percent decrease in ozone, and the y-axis is the percent increase in skin cancer. So composition kind of skips over the middleman. It removes that piece that connects the two functions together. It hides it. It doesn't remove it. It hides it. So now we're going straight from how much is the ozone changing to what happened with skin cancer. And on the top of that fraction is going to be the change in skin cancer, and on the bottom is the change in thickness of the ozone layer. So this one is telling me that for every 1% decrease in the thickness of the ozone layer, there will be a 5.25% increase in the cases of skin cancer. So again, notice that I always use both numerical values, the top and the bottom of the fraction. I always use their units. And I always say what's increasing, decreasing. So make sure you include all of that information. Okay, so lots of examples of interpreting slopes. We are going to do that a ton this quarter.